So we have this sec
Ha.
theta and tan theta.
So is what this identity is? A minus b into a plus b.
A
What it
square
is?
minus B square.
Okay, so a square minus b square. I told you when I taught you this
Uh-huh.
identity, I told you in place of a and b as a numbers, there can be polynomials, there can be trigonometric functions, trigonometric ratios, right?
Yes.
So think of that sec theta as a and tan theta as a b.
Okay,
Then
okay.
isn't it will be sec
Yeah,
theta
then I'll
minus.
use A plus B and A minus B.
Yes, a plus b and a minus b. Then it will be like what it will be like.
Will it get squared? Sec and tan?
Yes, obviously, as it's squared in the identity, no. So a square minus b
Then sec square theta
sec
minus tan square
square
theta,
theta
I think.
minus tan square theta. Because of that
Huh.
identity, a minus b
Hmm.
multiply a plus b is equal to a square minus
So
b
A
square.
square minus B square.
Right, very good. Okay. Now, do you remember three fundamental trigonometric identities?
Yes, in that we have an identity with sec and tan.
With sec and tan. What is that identity?
Sec theta plus 1 is equal to tan theta. Then 1
No,
plus tan theta is equal to
no,
sec
it is
theta.
not that. It is not that one.
Uh,
You just remember. Take your time, remember, and tell me neat
uh,
correctly.
uh,
First identity is sin square theta plus cos square theta is equal to 1.
1.
Second identity was
Uh, uh, I think I'm
huh,
not remembering. Sec square theta minus tan theta tan square theta equals to 1.
1 plus tan square theta is equals to sec
Equal to sec
square
square
theta.
theta.
And when you
Huh.
shift this tan square theta towards right side, you will get
Hmm.
sec square theta minus tan square theta. This is what is obtained here in this example, and it is
Hmm.
equal to its left hand side, which is 1. So this
So
is
LHS
from
equals
this
to answer.
identity 1. Understood?
Yes.
Okay, now write it down. Write it down
Okay.
means you just try yourself to solve, and whenever you in doubt, see to the screen.
Okay.
Okay, done with it.
Yes, 1 minute. Last one.
Last. Okay.
Done, sir.
Done. Now we have the next question. We have this as the next question. Have you noted this question?
No, 1 minute writing.
Okay. No, instead of you just tell me. uh,
Hello, yes, sir.
So let's solve this first and then you note it down. Okay.
Okay.
Now tell me step by step. We are starting with LHS, right? So LHS we
Yes.
have written. Now, what to do in the next step? See, I taught you this multiplication x plus y into a minus b, right? A binomial multiply with a binomial. How to multiply two
Yes.
binomials? Do you remember that multiplication of binomials?
Yes.
So
Yes.
that is to be
X
used here.
into A, X
Ah,
into B, Y into A, Y into B.
right, right. So what is x here?
1 minute. Yes, sir.
Sec theta. Okay,
In
into next.
consider, I
Into,
considered X as sec theta.
huh,
Huh. So
okay.
sec theta into 1
Next,
minus sin.
next bracket as it is. Okay. Now plus sign is
Huh.
there in between x and y. That is sec theta and tan
Yes.
theta. So plus sign written in between. And next
Yes.
y, that is tan
Tan
theta,
theta
into next
into whole
bracket as it
bracket.
is 1 minus
Huh.
sin theta. Now the multiplication of two binomials has turned into multiplication of a monomial with a binomial, right?
Yes.
So
Yes.
multiply this monomial with each term of the binomial. Then you will get 1 into
Yes.
sec theta as,
Sec theta and
okay,
sec theta
minus
into sin theta.
sec theta into sin theta, okay,
Plus
plus this tan theta
tan theta
minus
minus tan theta into sin theta.
sin theta. Very good. Now, what can be done with it?
Uh, can we square the sec theta and tan theta?
Why you are squaring? And which term you are squaring? As there are how many terms? One, two, three, four. Four terms are there. So why
Uh,
there is need of squaring? Instead, can you convert tan theta in terms of sine and cos theta, sec theta in terms of
yes,
sine cos
sin theta upon cos theta we can.
tan theta? Okay, and what about sec theta?
Huh. 1 upon cos theta.
So right in place of sec theta, 1 upon cos theta minus.
Hmm.
Here it will be what? 1 upon cos
1
theta
upon cos
into
cos theta.
sine theta plus this as sine theta, or let it be tan theta only. Let it
Okay.
be as it
Tan
is.
theta.
Tan
Huh.
theta minus it is what? Sine theta upon
Upon
cos
cos
theta
theta.
into sine theta. Right?
Huh. Yes.
Now see, it is 1 upon cos theta, okay, minus this is what? Sine theta upon cos theta it is. So will it be tan theta or what?
Tan theta. Yes. Tan theta.
Okay, and then plus tan
Plus.
theta here. That's why I kept it as it is. Didn't changed.
Huh.
Okay, minus this as sine theta into sine theta, sine square theta upon cos theta,
Cos
right?
square cos theta. Huh.
Now, can what can be done with it?
Hmm.
With this,
Can we convert tan theta into 1 upon cot?
why there is need, as there is, see, there is a minus sign over here, plus sign over here, and both the terms are of same
That
value.
cancel.
So
Cancel.
if this minus tan theta, this tan theta is subtracted from this tan theta, you will get its result to be 0. When it gets
Huh.
subtracted, then you will be getting answer like 1 upon
1
cos
upon cos
theta
theta minus
minus
sin square theta upon
sin
cos
square
theta.
theta upon cos
Cos
theta.
theta.
So it is like cos theta. See, the denominator is common. You can write it as it is common denominator as a cos theta.
Yes.
Okay, whenever denominator, and this also I taught you. See, a upon b
And
minus c upon d.
yeah,
Addition,
cross.
subtraction of rationals. At that time also I told
Hmm.
you in place of numbers there can be anything. There can be polynomials, monomials, binomials, trinomials. There can be surds. There can be trigonometric ratios, and here there are trigonometric ratios in place of that.
Yes.
When this b
Now
and
the
d
answer will be
huh, 1
now the
minus
answer will be 1 minus sin square theta, but 1 minus sin square theta is equal to cos square theta, right?
why
Identity is there, no? Sin square theta plus cos square theta equals to 1.
Very good. Sin square theta plus cos square theta is equal to 1. So when you
1.
subtract this from 1, you get
Hmm.
cos square theta. So it is cos square
Yes.
theta upon
Theta
cos
upon cos theta. So
theta. Yes.
1 cos theta and 1 cos theta get cancelled and cos
So
theta
this
is the answer.
square is cancelled with denominator cos theta, and final result you are getting is cos
Cos theta.
theta only, and which is nothing but RHS of the given thing. Okay.
Yes.
Understood?
Yes.
Is it that difficult?
No.
Okay. Now
Actually.
write it down.
Yes. Okay.
Now you tell me, is trigonometry difficult?
No.
Trigonometry is not that much difficult. Once you understand
Hmm.
basics, and you need to practice a lot. You
Yes.
you need to give time to the basics. Then only you will be catch the things, and then when things get harder and harder, at that time you
Hmm.
should cope up.
Yes.
You can easily cope up when you practice basic things only. Otherwise, the
Yes.
things get difficult.
Yes. Can I write?
Yes, write it down. Yes, done with it or not?
1 minute.
Okay.
Done, sir.
Done?
Yes.
Okay. So let's go towards next question. Now this one is sec square theta plus cosec square theta is equal to sec square theta into cosec square theta. See, what's the difference between these two? LHS and RHS. The only difference is here there is a plus and it can be converted into multiplication directly. So multiplication of sec square and cosec square is same as addition of sec square and cosec square. That is the result. Okay, so sec square theta plus cosec square theta is equal to sec square theta into cosec square
Into
theta.
cosec square theta.
Very good. Okay, now get started with LHS. Sec square theta plus cosec square theta. Start start simplifying it. What can be done? Think about it. See, whenever you are not getting what to do, try to convert. Whenever there is tan theta, write it in terms of sin theta upon cos theta. Whenever you are not getting anything, sec theta as 1 upon cos theta.
Cos
Cosec,
theta.
cosec theta as 1 upon sin theta, like that. Okay, so here there is sec theta, so it will be like 1 upon cos square
Cos
theta, right?
square theta.
Yes, it is
Yes.
like sin square theta.
Same. Huh.
Now do cross multiplication, use that
Huh.
stuff. A upon B plus C upon D is equal to AD plus
Uh,
BC upon BD. Use that part.
yes. So denominator it will be cos square theta into sin square theta.
Cos square theta into sin square theta. Very good. Numerator.
And numerator a will be sin square theta
Hmm.
plus cos square theta.
Okay. Now
That's it only.
that's it only. Now what will be next step?
One minute.
Hmm. Now what you can do with it? Hmm. What is it?
Okay, one thing we can do.
Huh.
Sin square theta plus cos square theta identity is there no is equal to 1. So 1 upon cos square theta into sin square theta.
Because of that identity. Right. Now
Yeah.
split the term C. A upon B into C. A upon B into 1 upon C. Or C, in place of A there is 1 C, then 1 upon A into 1 upon B. So can you write like cos square theta into 1 upon sin square theta? Now see, 1 upon cos theta is what? Sec theta its square into 1 upon sin theta is cosec theta its square. So it is nothing but cosec square theta into sec square theta or sec square theta into cosec square theta, whatever you in the sequence, whatever order you want to write it like that. It is nothing but the RHS. It was quite
Sec
simple.
square theta, sec square theta into cosec square theta.
Ha, right. What we used 1 upon cos theta as
Cos theta and 1 upon sin theta.
this again we used. These two things we used here. Write it now.
Okay.
Wasn't it quite simple?
Yes.
Uh, are you doing it yourself or what? Watching from the screen?
I'm doing myself.
Okay, doing it yourself. Very good.
Done.
Hmm. Now this is the next question for you.
Okay.
I have started from LHS. Now try to
Hmm.
complete it.
Okay.
Hmm. Did you get any idea?
No, I'm still thinking.
Let me give you a hint.
Okay.
Use that trigonometric identity, second and third identity. What is second identity?
1 plus cot square theta is equal to cosec square theta.
1 plus cot square theta is equal to cosec square theta, and 1 plus tan square theta is
Sec square theta.
sec square theta. Now shift this 1 towards this
Yes.
side. You will get, in place of tan square theta, sec square theta minus 1. So it is like minus sec square theta minus 1. Okay. And shift this 1 towards this side. You will get cot square theta as cosec square theta minus 1. Now open this bracket by multiplying by this minus sign to this bracket. So it is cosec square theta minus 1. This minus gets multiplied to this cosec square theta, sec square theta minus sec square theta, and this minus gets multiplied to this minus 1. It will be plus 1 there. Now see, it is cosec square theta minus sec square theta, and it is lastly minus 1 plus 1. So this minus 1 plus 1 cancelled, and we get cosec square theta minus sec square theta.
Sec square
It was
theta.
quite tricky. This trick we have not yet used. It was
Yeah, I did not understand this. So
it was not understandable easily because we didn't use this trick frequently or
earlier.
in so many questions we solved, but we didn't use this trick.
Okay.
So this way also you can use the identities. This is what was the purpose
Okay.
before this question.
Okay. Can I
Uh,
write 1 minute?
yes,
Wait.
write it down.
Hmm.
Write it or do it yourself. Try to solve it yourself.
Okay. Done.
Done. Okay. Now the next question is in front of you.
Yeah. Last question. Okay.
Okay. Next question.
उनके KLHS. Hello. Hello.
Ah,
Sir, your voice is breaking. You are saying something.
no. I was not saying something. I thought you
Okay.
will try it yourself. Give a try.
I took LHS.
LHS. Tan
Huh.
raised to 4
But
theta.
both the side we have tan, so I'm not understanding what to convert.
See, here there is a tan square.
Huh.
Here also there is tan square. So can
Huh.
you take this tan square as a common?
Oh, okay, okay, yes,
So
yes.
what else remained in the first term?
If tan square, one tan square theta is removed, then tan square theta, and tan square theta is replaced by normal one.
Okay, normal 1.
Huh.
Right.
Huh.
Now, see,
Now we'll multi.
we have this
Minus.
identity 1 plus tan square